Hello, geometry. Welcome to day 2 of finding areas of regular polygons. Okay, what you see before you is a pentagon, 1, 2, 3, 4, 5, 6, septagon or heptagon, octagon, decagon, and dodecagon. Okay, so I decided to pick a few that were really, this number of sides that were really kind of nice. But the interesting thing about these is you don't have any 30, 60, 90 or 45, 45, 90 bits going on. All you've got is triangles. You're like, what in the world should I do? So I wanted to just remind you / show you of how to find angles inside of polygons. Okay, so if I draw my apothem, not super straight, sorry about that, in a regular pentagon. Now remember that if I go n minus 2, 3 n minus 2 times 180, 3 times 180, the whole entire pentagon adds up to 540. If you divide that by 5, you're going to get 108. So this whole angle here is 108. But this is divided into 2 into 54, 54. So this is going to be 108 degrees, but this is going to be 54 degrees, which is cool. But the interesting thing about this is, I'm going to move this over to here so it's not too bright. The interesting thing about this is you could have done that from the center because the whole entire inside is 360, and 360 opens up to 1, 2, 3, 4, 5 different sides. So if you just go 360 divided by 5, you get 72. So this whole entire top is 72. That means that's 36. And what do you know? There's a supplementary or complementary pair, excuse me. Okay, so that's 36. I'll keep tilting this a little bit so it's not super shiny. Oh, there we go. That's not too bad. Okay, so then this guy here, I bet I could work on the lighting a little bit so it's not so bright. But this guy here, being a septagon, I'll do one of those two ways again. Probably, and you're like, well, what if I give you the apothem or the radius or the perimeter now? Well, now, if I give you the apothem, you can just use trigonometry to find all different sides. SOHCAHTOA, 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 SOHCAHTOA. What do you do when you stub a toe? You SOHCAHTOA. Okay, now, 360 divided by 7. 360 divided by 7, ooh, not too pretty, divided by 2, 25.714. Ew. 25.714 degrees is this guy. And of course, trusting our math, if we just go 90 minus answer, we can get the 64.286. 64.286 degrees, and that'll be that guy right there. Now that's kind of cool. Okay, so I'm going to use that. Octagon. Now octagons, I'm going to leave these all so you can see them. Octagons are cool because octagons, too shiny. Octagons, I'm going to try this. There we go. There we go. That's better. Okay, now octagons are great because, I'm going to zoom in here a little bit. Octagons are great because we know that we've got 8 sides and 360. 360 divided by 8. I guess I'm using this method because I like it. 45. So each of these is 45 opening up. But then if I split, so again, that whole dealio right there would be 45 degrees. But because each of them opens to 45, that means this guy right here is going to be half of 45, or 22.5 degrees, which its complement, of course, is 67.5 degrees. That would be good. Decagon, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Similarly, now I'm just going to focus on these two today. We're just going to use pentagon, and we're going to use pentagon and octagon today, which is really nice. We're going to use those two and use SOHCAHTOA with those, as we'll see. But there's going to be a couple bonus problems that I give you. We have these here as well. So what I'm going to do is I'm just going to find you the angles inside of a decagon. Well, of course, 360 divided by 10, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Good. 360 divided by 10 is 36. That means our top angle of this cute little right triangle is going to be 18 degrees, which would mean this is 72. Look at the old 72, 18, 90. This last guy, our dodecagon, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, is going to be, oh my lance out. Okay, so we've got a super skinny little guy. 360 divided by 12. 360 divided by 12 is 30. That means this is going to be 15. I can hardly even see that. 15. This guy will be 75 degrees, and then that's what we would do. So this is just how to find all the angles inside, all the angles inside of these shapes, with the ability to then use some sort of trigonometry as we're going. 8-sided, 10-sided, and 12-sided. So really, really nice. And then when we add in the apothem and perimeter, we will be able to use our trig to do 1/2 apothem perimeter and solve for these. These actually might be a little bit simpler than the ones with the special right triangles, because all you got to do is trigonometry to find it, and you don't have to remember all of your special right triangle rules. So on to video 2.